We're back on a 6.0 LS L96 engine, and this week we've been doing a lot of retro builds from the LS series, and we just did one on the L94. So you ask yourself, what are the advantages of the 6.0 L96? And I guess you can include the LY6 also, which we'll talk about. The L96 is probably the toughest, most durable engine out there today. The L96 was designed for a specific purpose, and that was for heavy-duty trucks. And we all know that heavy-duty trucks are not maintained as well as private vehicles. They could be in a glass truck or a garbage truck or towing a trailer, and the guys that drive them may not necessarily care about the powertrain. So the oil may not be maintained, the coolant may not be maintained. Maybe they're driving them at a high-duty cycle where they're floored almost all the time, going up grades. So these engines had to be tough. Now we have to go back to when the LS came in and the small and big block Chevys went out. That would have been the late 1990s. Chevrolet designed the all-aluminum LS engines, and this series of engines was a huge leap in technology over the old small blocks. The old small blocks and big blocks really had their roots in the 1950s, but the new LSs had skirted blocks, all aluminum construction, roller construction on the camshaft and lifters. Sure, you could put all that in an old small block, but you would spend a lot of money, a lot of time, and you wouldn't have something that came out of a factory that way. Those engines were excellent. If you remember the old 5.3s and 6.0s and the Escalades in the early 2000s, they really were great motors, and you still see a lot of them on the road today. Now the lightweight construction, higher compression, and all the other advantages that the original Gen 3 LS series had was huge. I remember doing 5.3 conversions in the old Chevy trucks that had the 5.7K motors. And even though we reduced the displacement, we increased the mileage 3 to 4 miles per gallon. And the horsepower jumped dramatically. We're talking about going from about 180 to 300 horsepower. And guys that were having problems pulling their trailers up hills no longer had a problem. So it was a huge double-digit leap in horsepower, torque, and everything else. And this was running 4-speed transmissions, remember. Well, GM had to have a heavy-duty truck engine, and they wanted something tough to replace the venerable big block Chevy and the small block Chevy. Remember, those engines were all iron, and they didn't run the latest and greatest in technology. I remember right before the big blocks went out, they started to add some serpentine belts and fuel injection, but really we were just putting makeup on a pig at that point. So GM designed the LQ4, the LQ9, and what they were iron blocked LSs. Going to the iron block obviously gave them more longevity and stability in operation. They put a lower performance head on it. They lowered the compression so you could run pretty much any gas that you wanted. The Gen 3 motors did not have variable valve timing, active fuel management, or any of the technologies that Gen 4 engines had, especially the 6L80 transmission. The 6-speed transmissions made almost as much of a difference as the engines themselves, so it's too bad the Gen 3s didn't get them. Now in general, in the Gen 3 6.0s, they ran the 4L80, which was the heavy-duty version of the 4L60 series. In the Gen 4s, they run the 6L90, which is the heavy-duty version of the 6L80. They run the same TCM. They're very similar in operation. The only difference is the 6L90 is stronger. So a lot of guys call me and say, can I run a 6L90? Yes, you can. It does take a couple of extra steps to support. One, we need to run a different input gear, which we do have available. It's a larger input gear than the 6L80. And remember, the 6L80 is running the old 4L80 output shaft. So that's massive. That's strong. The 6L90 is really meant for 10,000-pound trucks towing trailers, and it's just not needed in a JK. So the extra size, length, and everything else, you just don't need it. So if you can find a 6L80, go for it. If you got a supercharged monster engine or 45-inch tires, then yeah, go ahead and get a 6L90 and we can support it. Now be careful putting a 6L90 in a two-door, because that extra length is going to shorten your rear drive shaft, and if you got a lifted two-door, that can lead to some vibration problems with the drive shaft angles. So getting back to the Gen 3 LQ motors, they were excellent engines, and GM ran them for a long time, right up through the transition into the Gen 4 engines in about 2007. Now in 2007, GM offered the LY6, which is the predecessor to the L96. The LY6 is pretty much the same engine as the L96, except that it was not flex fuel compatible, and the earlier ones did run the older GM AC Delco map sensor and speed density system, where in 2009 they went to the later Bosch style system, which they've used right up through the end of life of the LS engines. So GM needed a heavy-duty truck motor, an engine that could go into the 3/4 and 1-ton trucks and be abused. We all know that the fleets, while some of them keep their vehicles up, some don't. These engines could end up in glass trucks, garbage trucks, towing 5,000, 10,000 pound trailers, have a driver that doesn't really care, going up a hill, floored all the time. They overheat them, they run them out of oil, whatever. So GM had to design a tough engine that could handle that environment. So the L96, the LY6, the LQ4, the LQ9, they were all really designed around that philosophy. Now these engines had iron blocks for obvious reasons. The iron's more stable than aluminum in the extreme conditions. In fact, GM went to their iron block for the LSX engines. Now it's not the same block as the 6.0, but you get the point. These engines had different heads than the half-ton high-performance heads. They were lower compression. They were designed more around low knock, meaning being able to run poor gas and not have pre-ignition. The whole engine was designed around hauling heavy loads as reliably as possible. These engines, taken care of, in my experience, can go in excess of 300,000 miles, which makes this engine one of the best values in the industry. These engines were not as desirable as the all-aluminum 6.2s and the other all-aluminum engines, even the 6.0s that GM produced. So you could find them in wrecking yards at a good price. And given the longevity of the engine, there's really not much else that can compare with it. Now you can compare it with the iron 5.3 like the LMG, and that engine has a similar lifespan and low cost and regular gas and all that. But the biggest difference is the 5.3 doesn't put out as much power as the 6.0. So if you have a lighter JK, the 5.3 is an awesome engine. If you have a midweight or heavyweight JK, then if possible, go with the 6.0. Check your local emissions regulations, because remember, this is a heavy-duty engine. A little bit about this Jeep, early JK. We've got the tap shift set for the steering wheel. So when I come back into the tap shift mode, it's going to say drive because we're in drive. Now what I can do is come here and bump it down using the cruise switch, which a lot of you guys think is cool. I prefer the toggle switch, which we've installed in this vehicle also. I don't know if you can see it. And that way the guy has a choice. He can just flip a switch and go between the two. So if you're off-road, you can use the toggle switch because it never changes its position. Up is up and down is always down. And then you can use the cruise switch on the highway, which works fine because you're not spinning the wheel around. You will notice several things about this dash. We got the ESP light on because the steering angle sensor is off. If you look, I'm going straight right now. You see how far that wheel is off? These JKs use 4-wheel speed sensors, one at each corner, and it feeds that to the ABS module. The ABS module averages it and then sends it throughout the rest of the network for like your speedometer. But using the steering angle sensor, there's a sensor inside the steering wheel that knows what degree the wheel is to the right or to the left. So it compares that to the 4-wheel speed sensor signals. So if you're going straight down the road and all 4-wheel speed sensor signals are saying 60 miles an hour, but your wheel is off 20, 30 degrees, then it's going to throw a code. It thinks there's a problem. That's why it's so important to center your wheel. I've been in some pretty heavy crosswinds where I've got to crank that wheel over to fight the crosswind and throw the same code with a vehicle that has the steering wheel properly centered. So keep that in mind. So getting back to the 6 liters, it culminated in the 6-liter L96. And the L96 is really a special engine. It had some variants like the LC8, which is a multi-fuel version of it. But essentially the L96 had no replacement in 2014 when GM went to the LT engines. So they continued to use the L96 in the heavy-duty trucks. In fact, they use them all the way up to the current. You can still buy a brand new vehicle with an L96 in it. GM has developed the new 6.6-liter iron blocked LT. They're working some bugs out of it. But the L96, the bugs were worked out on a long, long time ago. That engine was released in 2010. It is a phenomenal engine. It is about as reliable as you get. In fact, if I had to pick a engine to get through a desert, to get through a tundra, a frozen tundra, or I was in a foreign country where all I could get was really poor gas. And remember the old Chrysler engineers when they developed their turbine back in the late 50s and early 60s, their turbine car engine, they promoted that it would run on anything. And when they went to Mexico, they ran it off tequila. Now, I'm not saying to run your 6-liter off tequila, but if you're in Utah with really, really bad gas, and then you go to California and get oxygenated fuel, and then you go to back east where they have different fuel when they go from winter to summer fuel, the volatility changes. The 6-liter is going to handle it pretty much better than anything else out there. Now, as far as the construction of the 6-liter goes, like we said, it's got an iron block, which makes it really strong. It makes it less susceptible to the cold. It makes it less susceptible to the heat. It makes it less susceptible to low maintenance, meaning you run it low on oil, you run it low on coolant, you overheat it. Now, I will say the aluminum motors are really, really tough. I've never seen an aluminum engine damaged by heat because GM has a lot of hot protection modes built in where it starts dropping cylinders, richens it out, and everything else. So I'm not taking anything away from the aluminum engines, but the 6-liter iron engine is the engine I would cross the Outback or a desert in. Hot rodders are pretty intuitive, and after the 6-liters were released, they realized the strength of the 6-liter, its reliability, its iron block, etc. So they started to change the heads out, put the half-ton high compression heads in, the high performance heads. They would cam them, and these guys are getting 400 plus, 500 plus horsepower out of these 6-liters, and they're holding together. So when you put a 6-liter back to its stock configuration, which is about 330 to 350 horsepower, they can pretty much go the distance, 200,000-300,000 miles. You guys might remember the turbocharged Jeep I drove a few weeks ago. This engine may have slightly less horsepower than that Jeep peak horsepower, but when it comes to drivability, it's on a different planet. This 6-liter runs like a dream. It's completely linear. I got my cruise control set here on the same road, and yes, there's beautiful Red Rock, and you can see we're just putting along here at 1300 RPM, and there is no hunting. The turbo's not coming in and out. The transmission's not upshifting and downshifting. It's a completely different experience. Now, let's take a look at this Jeep real quick, because I'm going to tell you several things, and one of the reasons that we do these test drives is for me to identify these things and then correct them, even though they're not really part of the swap. So first, you see the steering wheel is off. That's going to throw codes, which it has. Second, the tachometer's off about 200 RPM. But more importantly, let's look at this coolant temp gauge. You can see it's to right of center. Normally, it's just to the left of center. And this vehicle right now is running at 192 degrees. The reason it's to the right of the center, and I will also say the fuel gauge is off. Usually the low fuel warning light comes on at about 1/8 of a tank, but this one's coming out at about 1/4 of a tank. Somebody had this cluster out, somebody had the needles off, and they just put them back wrong, so we will straighten them out. What you want to do after you take the needles off, let's say you put a custom faceplate on, is go into the scanner, go into the cab module or the cluster with a good quality scanner and do a reset on the module. Then do a test, and you're going to see the needles sweep their full range. And if they're not right where they need to be at 0, 1/4, 1/2, 3/4, etc., then you can tweak them. Just go in there and move them a little bit. I've built several of these for up north. I've got them in Newfoundland. I've got them in the Yukon. I've got them in Nome. And those guys up there prefer the iron blocks. Now, I've also got a lot of aluminum engines up there. I've got a lot of them in Iceland, even the LTs. And what you have to remember with low temperature conditions is if you have DOD, AFM, MDS, whatever you want to call it, similar deactivation, it's really important that you run the proper oil pressure regulators, because there's an additional regulator on the LSs in the oil pan. And I have guys take off the truck pan with a DOD regulator and put in an LS3 because it gives them more clearance, and then they're up in Michigan in a snowstorm and they start their engine up when it's 10 degrees out and they crunch their lifters. Now, fortunately, the 6.0 does not have active fuel management. It doesn't have the AFM lifters, and it does have VVT. So if you want to get the simplest engine possible, of course, look at the LS3. It's basically a 1955 small block Chevy upgraded. There's no VVT, there's no AFM, there's nothing on that engine that makes it anything but a pure track engine. Now, the 6-liter went to VVT for obvious reasons. By phasing the cam, they can get more bottom end torque to move the weight of that vehicle, and then they can get better performance on the top end by phasing the cam, retarding it, and getting it back to where they want it to be. So I'm a big fan of VVT, and the reality is if VVT fails, usually you're just stuck at one position. But I've never seen a VVT on one of these engines fail to date. Now, if you still say, I don't want VVT, well, then take it out. There's plenty of manufacturers that offer VVT delete kits, and essentially you're just going to get the non-VVT components from GM. It doesn't cost a whole lot. Change everything out, and for you guys that do have AFM, you can remove your AFM lifters at that point, change the cam, and then you have a non-VVT motor. Pretty much as simple as it gets. So let's try to address a question I get almost every day. Guys are trying to choose between the 5.3 LT and the 6.0 LS. As far as horsepower goes, they're very similar. The 6.0 has more cubic inches. The 5.3 has a lot of torque because of technology. It has that 11-to-1 compression and the continuous variable valve timing and the direct injection. So what that does is it allows that little 5.3 to perform right up here with the 6.0. So they say, which one do I want to get? And this is my answer. Now, 5 years from now, it might be different, but today, you can pick up these LS 6.0s for a song. Now, unfortunately, guys, GM is really backing off on the 6L80s, so the price has gone way up. The core price in the 6L80 has just skyrocketed. So we're actually picking up the 8L90s and the 10L80s for less money than the 6L80s today. So it's going to be tougher to find a low-cost 6L80. You can still find a relatively low-mile 6-liter with a 6L90 on it for a really good price. Remember, GM made these motors right up through 19. In fact, most of the 6 liters, low mileage ones that we're installing are 17, 18, and 19 engines. Some are even new production because you can still buy them new. These engines did not go out of production in 2014 like some of the others that are getting really difficult to find. And I can't really prioritize that over the 5.3 right now because the 5.3s, when they first came out, we were paying $6,000 for a used L83. Now they're about half that. So price-wise, I would say the 6-liter still has an advantage, but you can get the 8-speed with the 5.3, and if you want the 5.3 to perform with the 6.0, you're going to need the 8-speed. Complexity. The 6.0 has it all over the LT, and even the Hemi when it comes to complexity. And it's pretty obvious with the LT because of the technology in it. You say, why with the Hemi? Well, the Hemi does have an iron block, but the Hemi also has the overhead rocker tubes, and to get the Hemi design, they had to splay the rockers, and there's just a lot more stuff going on up there with oil pressure and stuff. They did have some issues in the early days. 6-liter don't have none of that. Performance. Well, again, the 6-liter and the 5.3 perform very similar. In different ways, the 5.3 has a lot of torque on the bottom end for 2 reasons. It's got the high compression and the CVVT, and then it's also got the 8-speed transmission. The 6-liter does it through pure displacement. So as far as actual drivability goes, there's not that much of a difference. Longevity. I think we have to give that to the 6-liter all day long. These 6-liters, like I say, even when not maintained properly, I've seen them go 250, 300,000 miles. I've seen camshafts wear out before the engines wear out. Guys put new camshafts in, and they continue down the road. Now, GM's cranking these 5.3s out, and we're going to see the price drop, and we're going to see more parts available for those engines in part stores and everywhere else. And that, again, is going to be another category, and that's availability of parts. Parts can be an important factor. Now, the 6-liter shares a lot of its components with the rest of the LS line, truck line that is. So if you look at the 5.3s, the 6.2s, the other 6.0s, the water pumps, the harmonic balancers, all the wear items, the coils, it's all interchangeable. And GM has just made millions and millions of these engines. You can go to pretty much any corner auto parts store and get the standard wear items for your 6-liter engine. Now, that's not so true on the LT 5.3. The dealers do stock most of the parts, but they're higher cost. If you go to your average corner auto parts store, they're going to have a lot of the parts, but they're going to have to order a lot of the parts where they wouldn't have to with the 6.0. We upgrade the tune in these, and we can get an extra 20, 30 horsepower out of them because, again, GM was very conservative on those tunes. They know that the duty cycle is high. They know that the operators don't really care. They're just going to floor the thing, and these things have to be protected. So they back off a lot of the engine performance, whether it's power enrichment, spark timing, etc. So by cranking in some spark and some fuel, you can really wake these engines up. In fact, the Jeep I'm driving right now is amazingly zippy. If you drove this Jeep, you would think I had a 6.2 in it. So we'll see you in the next video, and we got a lot of 10 speeds and LTs and LT4s and all sorts of stuff coming up. So this week has kind of been, or this month has kind of been older technology and turbochargers and stuff, but we're gonna step that up in the next few videos. Thanks.